Hi guys, so today we are going to go over section 5.1 and this chapter is about polynomials. But before we talk about polynomials, let's talk about a monomial. A monomial is basically a number, a variable, or an expression that consists of just the product of one or more variables or numbers. So there are no, addition or subtraction operations involved, just multiplication. How do you know when a monomial is simplified? Well, basically, there should not be any powers of powers. Each variable should only appear once. Fractions should be in simplest form. I mean, that should be the case anytime, right? Like, don't ever be walking around with an unsimplified fraction. There should be no negative exponents. This is a big one. That's why it's in bold. Never any negative exponents anywhere. Also, you should not have any roots of variables. So for example, 3xy is a monomial. X squared y cubed times z is a monomial, right? All of those are monomials. Now, you can also have, like some fractions. So for example, 1/3 x squared y is also a monomial. A polynomial is it could either be one monomial or it could be the sum of monomials, right? So for example, x plus y is a monomial, x squared y minus 2xy squared is a monomial, and so on. I'm sorry, is a polynomial, and so on. So these are all polynomials, right? This one has two terms, the x and the y. This one has two terms, and so on. Now, the degree of a monomial is the sum of the degrees in each variable. So, if you have 3x squared, the degree is 2. Now, if you have 5x squared y cubed, the degree is 2 plus 3, 5. Okay, so it's the sum of the degrees of each variable. Now, the degree of a polynomial is the degree of the monomial with the greatest degree. Okay, that's kind of confusing, right? So suppose you have x squared y plus x cubed y squared, right? This has a degree of 3, right? 2 plus 1. This has a degree of 5. So the degree of this one is 5. Okay? And then if you have, let's say, 5x to the 7 minus 3x cubed plus 2x squared, then which one is the term with the highest degree? That's this one. So 7 is the degree. All right. So state whether each of these is a polynomial. And if it is a polynomial, state the degree. This one is not a polynomial because you have this variable in the denominator. So this is not a polynomial. This one is a polynomial. You can see there are no negative exponents. There are no variables in a root. There are no variables in the denominator, right? So this is a polynomial. And now as far as the degree, so let's see here, this monomial has a combined degree of 6. This one, haha, look at that, our favorite combination. This one is a 2, so the degree of this is 7. Okay, product of powers. If you have powers that you are multiplying by each other, then look at this. If you have the same base and different exponents, then you keep the base and you add the exponents, right? We know this, like x squared times x to the 4 is x to the 6. Now, if you are dividing powers, if you have the same base but different exponents, you subtract the exponents. If you have a negative exponent, the negative exponent will make the power go either to the denominator or to the numerator. So basically it will have to switch position. So for example, if you have x to the negative 3, that's actually 1 over x to the power of 3. Similarly, if you have xy to the negative 2, that, right, if you have a fraction, then the fraction becomes its reciprocal to the power of positive 2. Okay, if you have a power of a power, 1 base to the power of a to the power of b, you multiply the exponents. If you have xy to the power of a, you essentially distribute, right? This is x times y, right? It's a product inside the parenthesis. You distribute and each gets their own. Same with the division. And then we talked about a negative. If you have x over y to the negative a, first take the reciprocal. X over y becomes y over x, then we distribute. And anything to the power of 0 is 1. So, once again, to simplify expressions, you have to rewrite without the parentheses, combine all the common terms, and no negative exponents. Okay, so let's do a couple. This one here has a negative exponent. So the first thing I'm going to do is I'm going to take the reciprocal to the power of 2. Now, I distribute. So this is going to be 2 squared over 3 squared, 4 over 9. Here, I have one base, that's n, another base, that's the n. So basically you have two bases that are the same, and the powers are being divided. So this is going to be n to the 2 minus 10. This is n to the negative 8, but I can't leave it like that, right? That's a negative exponent. So it'll be 1 over n to the 8. Okay, this one is this whole thing to the power of 0. That's just 1. Okay, here, let's simplify. We need to combine all of these and simplify the exponents. So let's see. First, what I want to do is I want to take care of the coefficients. 2 times 3, this is equal to 6. Then let's take care of the a's. A to the negative 2, a to the 3. I'm multiplying those, so I add the exponents and I get a to the 1. Then I have b squared that doesn't have a pair. Then I have c to the negative 2, right? Now, the only thing left to do here is to get rid of that negative exponent. So what I need to do is move the c to the denominator. 6 is to the power of 1. That has no issues. A has no issues. B has a positive exponent, no issues. The c moves down, it becomes c squared. Okay, here, let's distribute this to everybody. Before we do that, you would have had to look inside the parentheses and see if anything needs to be simplified, but there isn't such a thing. So what I get here is, look, negative 2 cubed, a to the 4 cubed, b squared cubed. Negative 2 cubed is negative 8. A to the power of 4 to the power of 3, I multiply as a to the 12 over b to the 6. Okay? All right. Here we are subtracting two polynomials. We're going to distribute the negative. So negative x squared minus 3x plus 4 minus x squared minus 2x plus 5. Negative x squared minus x squared minus 2x squared. Negative 3x minus 2x minus 5x. 4 plus 5, positive 9, and that's it. We're done. Okay, this, we know what to do. We distribute. So I get 6x cubed minus 12x, and we're done. Okay, here, I'm going to distribute, right? So here I get 4 over 3 times 6, right? That's going to be 8. And then here, x squared times x squared, x to the 4. Plus 4 over 3x squared times 9x. The 3's reduce to a 3, so 12 x squared times x, x cubed. Here, 4 over 3x squared times negative 12. The 3 and the 12 reduce to a negative 4 times 4, negative 16x squared. Okay, and that's it. We're done. Okay, here, let's distribute. So I have this times this. So first of all, I have negative 3. Okay, a to the negative 3 times a to the 3. That's a to the 0. I add the exponents. B squared times b is b to the 3. Okay. Plus 4. Okay, a to the negative 3, a to the 2. I add them. I have a to the negative 1. B squared, b to the minus 1. 2 minus 1 is b to the 1. Minus 5. A, okay, so exponent is negative 3, 1, negative 2. B, 2, minus 2, 0. Okay, now we need to clean this up a little bit. All of these to the power of 0 are going to become 1s. But the issue here is that here I have a to the minus 1. So let's take care of that when we get there. First, let's see how many different terms do we have. 1, 2, 3 terms. You really have to do each of the terms separately. So this is negative 3, a to the 0 is 1, b cubed. Plus, here is where the change needs to happen. The 4 is fine, it could stay there. The b is also fine, it could stay there. It's the a that we have an issue with. A to the negative 1 has to go down and become a to the 1. Now, look at what's important here. That a to the negative 1 only belongs to this term. Imagine this whole thing, it's a street with 3 different houses on there. This a lives in this house. It can only stay in that house. So you only put it under the 4b. Same with this one. Minus 5 stays. Now the a to the negative 2, that needs to go down, but only below the 5. So it becomes a to the positive 2, and then b to the 0 is 1. Okay, so that's it. We're done. Okay. Next. Okay, this we're going to distribute. So first, let's do the x, right? So this is x cubed plus 4x squared plus 16x. And then let's do the negative 4. Negative 4x squared. Let me use a different color. Negative 16x. Negative 64. Finally, let's reduce. X cubed. 4x squared minus 4x squared goes away. 16x minus 16x goes away. Minus 64. Oh my god, how cute is this? Okay, here we go. This one, I have 3 binomials. Divide and conquer. First, let's do this one. Okay, a plus b, a minus b, this is a pattern, right? So we square the first one, we square the second one, we put a minus in the middle. If you want to do the long foiling, that's fine, you still get the same answer. Times 2a minus 3b. And now let's distribute. Let's do the a squared first. 2a cubed minus 3a squared b. Now let's do the negative b. Negative b squared, it becomes negative 2ab squared. Negative times negative is positive 3b cubed. Scan to see if there are any like terms. There are not, so we're done. Okay, last two. All right, so look at this one. This one has a lot of stuff happening. First of all, there's a whole bunch of stuff inside the parentheses that we need to take care of. Remember PEMDAS, it's parentheses first, then exponents. So let's take care of the stuff in the parentheses. Now, a word of sisterly advice to you guys. When you're going to simplify the parentheses, please do this. First, do the skeleton to the power of negative 3, because if you start working inside the parentheses, you might forget all about that negative 3, and then you're pretty much done, right? Okay, so let's see. 2 over 3, those can't be simplified. Okay? Now, here I have, for the x's, x to the 2, x to the negative 4. So this is going to be x to the power of, look, I have 2 minus the stuff underneath, 2 minus negative 4. I'm going to move this away a little bit. Okay? Then what do I have? I have the y. Y to the power of negative 3 minus the exponent in the denominator. So let's see what we got. 2 x to the 6 y to the negative 8 over 3 to the power of negative 3. Now, what do I got? What's going to happen to the y to the negative 8? That's a negative exponent. Let's make it go down. So now I got 2x to the 6 over 3y to the 8 to the power of negative 3. Okay, so I did inside the parentheses. Now I have that pesky little negative exponent. You know what we're going to do? To get rid of the negative exponent, we're going to take the reciprocal of the inside. Now this becomes to the power of 3. Okay? So let's distribute that cube. 3 cubed, 27. Y to the power of 8 to the power of 3, y to the 24. 2 cubed, 8. X to the 6 to the power of 3, x to the 18, and now we're done. Last but not least, I got a binomial 2d minus 3 cubed. Okay, one way to do it is write it like this. And you're gonna, basically do it like we did h, like multiply the first two, then the other two. Or, if I were doing this for myself, here's what I would do. So basically I have 2d minus 3 cubed, right? So I have 3 of them total. That's the same as if I had 2d minus 3 squared, 2d minus 3, right? That's a total of 3. Squaring this is easy because I square the first term, I square the last term, and inside I get 2d times negative 3, negative 6d, times 2, negative 12d. See how fun that was? Okay, now let's do the 2d. Okay, 8d cubed minus 24d squared plus 18d. Okay, now let's do the negative 3, right? 12d squared. Ooh, I heard you. Negative 12d squared. Positive 3060, my goodness, minus 27. Okay, are there any like terms? This and this are like terms. It's tricky to have a 6 and a D next to each other. 18D and 3060, that's a whole lot of D's. What is that, 64? No. 54? Yep. And then minus 27. Okay? And there you have it. Yay. That's section 1. And now you can do your homework. Thanks, everyone.